it up because I grouped them so I could rescale them, and that probably messed up the animation. So sorry.
Okay, thank you all very much for hopping online today over your lunch hour. Feel free to munch and watch at the same time. My name is Lynn Dahman. I am the Managing Director for Purdue's Institute for Sustainable Future, and am totally thrilled to be working today with co-sponsors from the Indiana Water Resources Research Center, as well as the Indiana State Climate Office. Those of you who might have heard about some of our water work in the past that we have on occasion done in person, and then a while ago online versions of a happy new water year. But this time is the first time we're really pushing this out a little bit more broadly, and we're excited to be joined today by two experts in this field. So the first is Dr. Keith Shirkauer, who is a professor in agriculture and biological engineering at Purdue. He is also the director of the Indiana Water Resources Research Center and a past co-lead for the ISF Water community. He works in integrating field observations, remote sensing products, and hydrology models to address questions and concerns related to environmental change and furthering our understanding of land-atmosphere interactions and the hydrologic cycle. Beth Hall is our Indiana State Climate Office Director, located in the Department of Agronomy at Purdue University, and the director of the Midwestern Regional Climate Center. And as a lead of that program, Beth promotes the services and talent of the staff and the center in coordinating and collaborating with other regional climate centers, with NOAA and other climate service agencies across the United States. Her professional interests include applied climate, weather, and/or science research, contributing to the advancement of understanding of environmental relationships, data acquisition, and product development. And this is the first time we've kind of combined more explicitly climate in the services of the Indiana State Climate Office with our work on the Water New Year. So that's a pretty exciting, I think, pairing for today. And I will be handing this over to Keith, who will kind of go back and forth with Beth to present the content for today's webinar. Keith?
Thank you, Lynn. I will point out that we did do this joint with the Climate Office the first time, I think, but it has been years. So it's nice to bring the Climate Office back into this celebration for the new water year. And there we go. So the question today that we're trying to answer is, was 2025 a good water year? For those of you unfamiliar with the concept of a water year, it is the 12-month period that extends from October 1st of one year through September 30th of the next year, with the water year 2025 ending on September 30th, 2025. Why do we use the water year? And the water year tends to be is defined by the United States Geological Survey and is used nationally, but in general, it is to minimize errors due to groundwater, soil moisture, and snow storage. So by picking end of September, early October, that is when surface storage and groundwater storage tend to be at their minimums. So changes between years are relatively minor, right? And that is that change in storage, what comes in, what goes out, is really what we're trying to quantify over the course of a year. Why are we doing this in November? Mostly because it takes some amount of time, usually about a month after the end of any given water year, to get all of the data up to date on all of the servers that we use. And so I like to have that little bit of a delay so that we can have the best quality data for the presentation. And so to get things going, I'm going to pass it over to Beth, because rainfall is the primary source of our state's water resources. So we're going to start our review by looking at weather in the state.
Thanks, Keith. Next slide. All right. So when I was looking at the water year for Indiana, I was trying to figure out, well, did we make any records? And I also looked at temperature with this. So even though we think of water as precipitation, including snow, sometimes from climatology, we want to think, well, what was it temperature-wise as well? You'll see below the table, though, I have highlighted the word August because Keith just said a water year is October through September, but we get this data from federal collection networks. And if you haven't been paying attention to the news, the government has been shut down for a while. So we did not have the data through September in time for this. In fact, it probably will still be a couple of weeks while the government gets back. But let's look at how this all fell apart here over that not 12-month period, but the 11-month period. If we look at just temperature, maximum, minimum, and mean, the top 3 rows, how this last year, I show the ranks. So they were all in the warmer period. This is over a 131-year period from 1895 to 2025, keeping in mind that a water year does bridge a calendar year with that. It's not surprising to me that we were in the warmer, say half or third or even quarter of that long time period, because that's just what we're seeing with climate change and global warming occurring. So, but we didn't make records with this. I also have in the other columns what the average temperature was for this water year compared to what the normal is. That normal is a 30-year period. And then I even highlight what those record years were both at the extreme tails of that 131-year period. So a lot of diversity. Certainly the 2011-2012 water year comes up as the hottest on record for the state of Indiana, which probably isn't too much of a surprise when we think about that was a major drought year, which is another reason why we got to think of temperature with precipitation, because high temperatures usually feed in to strong drought connections. They sort of feed off of each other. So that's where we were with temperature. With precipitation, you can see we came in 46th wettest, not driest, but wettest. So it was a pretty wet year, not certainly record breaking by any means. And then I show that we got as a state the 39.46 inches. That is slightly below normal, not too bad. And then I show what the record year were. And if we call the driest year is at the 24 inches, which is back in the 1930s, where we call it fondly the Dust Bowl era. Next slide. So I wanted to look at the full 12-month period, and this does now include the 12 months, but I couldn't do it for a state. And I wanted to look at this in terms of extremes, because just trying to capture a year tends to wash out the noise that we want to think about. So going along the x-axis from left to right for all 3 of these time series, if you will, is the year starting from October 1 all the way through the end of September this last year. And then those tan vertical lines is kind of denoting the beginning of each month. And I chose 3 different cities across the state: South Bend, Indianapolis, or Evansville, to see were there any seasons throughout the year that stand out. Record warmth, I highlight that on the far left, happened right around November 28th of last year. Also, let me explain the shading you see. So the actual blue bars are the daily range of temperature. The blue shading down below on each of those kind of shows what the record range was, and the low end, and the pink is the record high end. So anytime the blue bars hit the top of the red line, that means that was a record. And then anytime the blue bars hit the bottom end, that would be a record low for that date. And so we can kind of see how those blue bars fit within the climatological range of temperatures within the year, because we almost got to think seasonally or even subseasonally. I highlighted then the springtime, and I just was looking at how much variability, how many major swings there were throughout the winter first. And that was really seen in all 3 cities, whether on the northern part, central, or southern part of the state. It didn't sort of calm out. We were going from one extreme to the next. And then moving into the spring, things are bunched up a little bit more, showing that there's less variability. But we were hitting some record warms. So you can see where those blue bars were touching in some cases, the very top of the pink shading. After the spring, though, variability was not as wide as it was at other times of the year. So that's, again, we got to think of, even in terms of water availability, drought, and so forth. Well, what time of that water year were we thinking about? Next slide. This is also looking at the 3 cities that I showed before, again, for that 12-month period from October 1 on the far left all the way through the end of September of this year on the far right. And what this is doing is the green is showing accumulated precipitation at those cities. The straight black line on each of these is what is normal for the normal accumulation for those. And what we see is anytime that green line is below the straight black line, that's when we have drier than normal conditions. The precipitation total accumulation throughout the year just hasn't even caught up to what normally happens. So really the story that we've been facing for the year is the northern part of our state has been on the dry side. According to the U.S. Drought Monitor, things have been in at least abnormally dry, if not moderate or even extreme drought. By the time we move southward to Indianapolis, you can see there were times in the spring where the central part of our state was certainly drier than normal, but it seemed to catch up on precipitation from about April through July, and then it dried off again. The exception, though, is the southern part of our state. Notice how down in Evansville, that green line almost throughout the entire year, with the exception of the first couple months, is higher, greater than that straight normal accumulation line. So the southern part of the state was facing quite a bit of precipitation. In fact, during statewide calls and even local calls with counties down there, I was hearing folks saying that in July, they had yet to recall mowing their lawn when the lawn wasn't soggy. So it was extraordinarily wet down there. If you look at the Evansville line, though, near the end, where it's like halfway through July into probably halfway through September, that green line flattens out. That's when really across the state, we stopped getting precipitation, because anytime the green line is flat, that means we aren't accumulating anything. And so it's starting to catch up. So there are areas in the South that might be just grateful that it's not a swamp down there, but they have a ways to go. Next slide. The other topic I wanted to bring up was severe weather. So this is a map that is really just for 2025 up through even this week. So it does go beyond the water year. However, I didn't include the months in 2024 because that map was pretty much blank. Most of our severe weather happens in the summertime, or at least from about March through October. So I felt like this was representative of it. The red icons represent tornadoes, the blue are severe winds, and then we had some hail reports, 69 hail reports. Certainly what we see in this map is there's a lot of blue, and the blue can also exacerbate drought. Wind can increase the evapotranspiration of any moisture. So where we might think we've gotten a lot of precipitation, if we have wind reports, and they don't always have to accompany thunderstorms, that can dry out vegetation, dry out the soils, etc. And so those were things that we were keeping an eye on. So how much wind, how hot was the temperature? So relative to not just thinking of precipitation, what other factors were going on in this past water year? Next slide. I did want to point out, so it's the same essential map that was on the previous slide, but this is just highlighting the tornadoes. And we can see that in 2025, we've had 64 tornadoes. These are preliminary, which means they haven't been totally vetted, but it's what has been submitted for thorough vetting. And down in the bottom red box, I show that the annual average number of tornadoes for Indiana is 22. So this last year was considered a relatively active year with respect to tornado activity. As far as was it more focused in one part of the state versus another, one could argue that the southern part got more tornadoes, but really throughout the entire state, they were experiencing these strong storms. Next slide. All right, Keith.
All right, we're coming back to me. So thank you for your synopsis of the weather. Let's look at water resources now. Losing focus on that. So water resources are not just about rainfall. Water resources typically are defined as a sufficient volume of water available of a quality suitable for its intended use when and where it is needed. That means we need to talk a bit about water supply, demand, water quality, and the social political context. So to get started, we're going to look back at water supply in 2025. We're going to start with surface and groundwater, talk a bit about droughts and reservoir storage. This is showing you rankings for groundwater wells on the left-hand side and surface water, so stream flow gauging stations, where the mean annual value for that station is ranked versus the previous 29 years. So it gives us a consistent 30-year period that we can look at things. Groundwater is based on the depth of the groundwater table below the ground surface, so that when groundwater is considered to be increasing, that means that the groundwater table is getting closer, rising and getting closer to the surface. Stream flow is based on changes to observed stream flow at USGS gauging stations. And everything is ranked based on a percentile. So the 100th percentile would mean it was the wettest of the 30-year period. So the wettest year of the 30-year period. The 0th percentile would be the driest of that 30-year period. 50th percentile puts it right in the middle. So, right, so 50th percentile is equal to that 15 out of 30 event. So groundwater in the past year, 22 of 32 locations were at or below the 25th percentile. So that would be considered extremely dry. You can see that it doesn't, most of those are in the north, but almost every one of the groundwater monitoring wells in the state is drier than normal, was drier than normal in 2025, with 3 exceptions. As far as stream flow, 71 out of 112 stations were at or below that 25th percentile. Again, just like Beth was saying, northern part of the state was more in water deficit, and you can see a lot more of the dark brown colors indicating much lower percentiles, whereas the southern part of the state, stream flow was at or above normal. So similar to that precipitation pattern she was just talking about. We can pull out a few snapshots. So looking at the Wabash River at Lafayette, so you can see that that one is a very dark brown, very close to the lowest flows in the last 30 years. So this is the daily stream flow metric. The red line is showing what the USGS gauging station here at the Brown Street Overlook was indicating. The blue line is the mean discharge on that day for the past 30 years. And then the gray lines behind that are indicating actual daily stream flow for the last 10 years. And so you can see that for most of this past year, that red line has been at the bottom or very close to the bottom. Exceptions would be around that April, and Beth pointed out that we had some big precipitation events in April, and also early January, when there was some events that allowed some recovery to the stream flow. If we look at groundwater wells, so just picking Tippecanoe 8, which is the groundwater monitoring well here in the state, same thing on this time scale. So the red are the observations of water table level in the water year 2025. Blue is the 30-year average, and the gray lines are showing each of the last 10 years. So you can see that almost the entire year, that red line is the lowest water table that we have experienced in the last 10 years, and it is well below the 30-year average, well below being about a foot lower than it has been in the past. We can also use that same 30-year time period to look at trends. So these trends are based on the 30 years of observations at each of those locations. Increasing trends in groundwater mean that the water table is going up, so it's getting closer to the ground surface. Increasing trend in stream flow means that that observed discharge has increased at the locations. Statistical significance on this test is at a 10% level. So triangles here are pointing up and are blue colored if we are seeing an increase, and red and down if they are showing a decrease, and that they are shaded if they are statistically significant. So you see that most of our changes are not statistically significant. Of the groundwater, 25 of the 32 monitoring sites are decreasing. 8 of those are significant. 2 of them are increasing significantly. So most of the groundwater tables have decreased, have shown some decrease in the last 30 years, but not much of it has been statistically significant. Of the surface water sites, 72 of the 113 sites that were used have been decreasing. Only 2 of those are significant. And this did make me go back and look at my 2020 maps, because I remembered at that point that I thought almost everything was increasing, and I was right. So there has been, as that 30-year period has shifted in my analysis, the last several years have been getting drier, and it has shifted that 30-year trend from slightly increasing to slightly decreasing. None of that is statistically significant, so it is more or less stream flow isn't changing at most of these sites in any kind of significant way. We can also look at reservoirs. So this is looking at the Eagle Creek Reservoir, same kind of plot. Current year is the red line, blue is the 30-year mean, and the gray lines are showing you the last 10 years of water levels. Now, most of these reservoirs are highly managed, so there's not going to be a lot of variation in them, but you can see that Eagle Creek Reservoir did start the year out above normal, stayed above normal up until they filled the reservoir in March, going into April. It remained relatively flat and then has dropped off kind of at the average rate in the last couple of months. If we look at drought conditions, so this is the U.S. Drought Monitor map for Indiana on September 30th, 2025. So the last date that they created this map for the 2025 water year. You can see at the time that 92% of the state was considered abnormally dry or drier. 52, so just over 50% of the state was considered in a moderate drought condition. 14% in a severe drought, and about 1% in an extreme drought, with nothing in an exceptional drought. So it's fairly equivalent to the same map at the end of the 2024 year, though the intensity has gotten slightly higher. And where that most extreme intensity has moved a little bit in the state. And if we look at the time series of how drought has changed over the course of the last water year, you can see at the end of the 2024 water year that we were basically 100% in the dry category, about 70% in the D1 category. We kind of remained there through the end of 2024. As we got into 2025, we did get some precipitation. Things decreased, but it wasn't until about when we got those rains in April that most of the state finally broke out of drought and extreme dry conditions. They kind of stayed static through the growing season, and then in the last couple of months of this water year, the area of the state that is under drought conditions has increased. So slightly better, 90% instead of 100% at the end of last year. So moving on to a couple of other slides that have some other factors affecting water resources. I'm going to talk a little bit about water quality, water demand, and legislation, new laws that we will cover. Water quality, I use basically the IDEM's list of 303D list of impaired waters. So that's a federal EPA standard. Just looking at category 5 situations, these have at least one user impacting impairment and require an assessment of total maximum daily load, or a TMDL, to be filed at that site. In 2022, there were 4,307 reaches that were listed. As of 2024, when I downloaded the spreadsheet this week, there are 4,324 stream reaches in Indiana that are currently on that list, so a slight increase. Many of those reaches are listed more than once, so there are 6,535 listings. So some of them show up twice or more. As far as what the impairments are, E. coli continues to be our biggest concern. Biological integrity and PCBs in fish tissue would be the next two. Dissolved oxygen and nutrients. A bunch of other things, but most of them are much more limited in where you're exposed to that in the state. Water resources demand, IDNR tracks significant water withdrawal facilities in the state. There are currently registered 7,631 groundwater wells that are considered significant water withdrawal facilities. And I think that's 10,000 gallons per day, but I didn't write that down, so it's not in front of me. That's an increase of 81 in the last year. There are 1,261 surface water intakes also listed in the state, and that is a decrease of 10 since the last year. The heat maps on the right kind of show you generally where those are. So there's a large clustering of groundwater wells, in particular in the northern part of the state. That is mostly for irrigation use. There's also a clustering around Indianapolis and Lafayette and down lower on the Wabash, which would be urban centers, industry, and thermoelectric power generation. Surface water intakes tend to be on the larger rivers, the Wabash River, the Ohio River, around Indianapolis, and then also on Lake Michigan. One of the things I did want to bring up, I don't really have anything to introduce to the conversation other than that this is coming up, but we are watching emerging technology water use, things like chip manufacturing and data centers and AI centers. So Indiana, along with a lot of other locations in the US, are having to deal with a substantial growth in these technologies. And many of these have potentially large water uses. A lot of it, like data centers in particular, tend to be for cooling systems as opposed to other uses. I would say in 2025, when I just checked, there are 4,189 data centers in the United States. Indiana currently has 75, the map kind of generally showing where they are. That puts Indiana as the 17th, or having the 17th most data centers in the United States. With Illinois and Ohio, our neighboring states, being 4th and 5th, we are in a position in the country where there is a lot of this activity going on. And I imagine we would start seeing the impact of this increased water use in future water year summaries. And then my final slide in this section is bills impacting water resources from the 2025 Indiana legislative session. I will point out that there were over 50 bills introduced, and more than just the 3 that I'm highlighting here that were passed. So it was a big year for thinking about what we should be doing in water use and water management. And I hope that we can continue to kind of think about that at the state level. But the 3 I do want to highlight, Senate Bill 28, which creates provisions for responding to groundwater emergencies and provides protections for Indiana farmers by establishing a process for large irrigators to be compensated for loss of usable water. So kind of in response to this growing large water demand from emerging technology centers and emerging industries. Senate Bill 4, which creates a permitting system for transfers of water out of a basin that exceed 30 million gallons a day, kind of in response to some of the things that have been in the news in the last few years. And then Executive Order 2563, which requires a detailed inventory of Indiana's water resources and mandates the development of a framework for water planning in the state. And now I'm going to pass it back to Beth so that she can share with you some of the forecasts of what's coming.
All right. It's always that crystal ball, and everybody kind of wants to know this time of year, is it going to be a snowy winter? How much snow are we going to get? How cold is it going to be? And so forth. So I have some good news and bad news for you. And I don't even know, if you are wanting a lot of snow or not. So let's go to the next slide. And this will be in just a few time increments. So the first is this 8 to 14 day outlook. It's representing kind of right leading up to Thanksgiving that day, so in about 2 weeks. And it's saying on the map on the left is how much confidence we have that temperatures will be above or below normal. So you see there's red colors that's over the Indiana area, and they're pretty good red colors. And so what that's telling us, and these are coming from the National Oceanic and Atmospheric Administration, that there is significant confidence that the temperatures over that period are going to be warmer than normal. Now, we're not talking triple degree temperatures or anything, but we are saying that they should be nice and comfortable. So for those of you that were shocked by the very cold temperatures that kicked off this week, I would think that this outlook is suggesting things should be warmer and more pleasant, not necessarily swimsuit weather, but unseasonably warm. And then the map on the right is a similar layout except for precipitation. And you see most of the country is shaded in green. And again, that is giving the level of confidence we have that the conditions will be wetter than normal. So in neither one of these maps is it saying how much warmer than normal or how much wetter than normal. It's just telling us that we are anticipating wetter than normal conditions and warmer than normal conditions for that time period. Next slide. The seasonal outlook. So this was a new one will be released next Thursday. So this one is slightly outdated, but it is to represent the 3-month period of November, December, and January. So our maybe a month too soon for our classic winter. Same idea with the shading. So what it's saying on the left is that we have slight confidence that the temperatures over that 3-month period will, when averaged together, be warmer than normal. Now, does that mean we will escape any cold waves that come through like we had earlier this week? Usually December has a couple good cold waves as well. But overall, if we were to average all the daily temperatures for that 3-month period, we are anticipating that that average is going to end up being warmer than normal for Indiana. For precipitation, this should be good news for those in the northern half of Indiana that just seem to always miss out on the precipitation. There's a slight confidence that this 3-month period should be wetter than normal. However, I will caution that these models take into account a lot of things one might ask, how do these models know what's going to happen in the next couple of months? And one of the drivers of these models is what we call climate teleconnections. And there's probably 10 or 15 known, and these are global climate teleconnections, but probably the most famous one is the El Nino La Nina circulation. And you'll see in an upcoming slide that tends to favor, when we are in a La Nina phase, it tends to favor wetter than normal conditions in our area. So the question is that really going to happen? How strong is this La Nina signal, and so forth? So it's just a slight hedging, these models, that 3-month period is going to be wetter than normal. And again, we could go from some pretty major swings back and forth. Next slide. For drought, this is the seasonal drought outlook. So again, representing November, December, and January. Now, Keith showed where we ended up at the end of September. Since then, the southern part of the state is almost drought-free, kind of with that diagonal line that you see shown on this map that's like an olive green. What it's saying is between now and the end of January, where you see the tan shading or the gray shading that's within the green in Indiana, we expect that to still stay dry. We expect that the drought will persist. And then the olive green area, we will expect some improvement. And part of this is for a couple of reasons. First of all, that's not our rainy season time of year. So the fact that we are already in a precipitation or a deficit, a water deficit in that tan gray area, we just don't anticipate seeing so much precipitation over this 3-month period to get us out of that deficit. However, along the edges of that driest area, we do think that there's a pretty good chance that with more upcoming precipitation, particularly those climate models favoring above normal precipitation, we could see improvement there. Next slide. All right, so I had mentioned a couple slides back about the El Nino Southern Oscillation, and right now we are in what is called a La Nina phase. So that's the exact opposite of El Nino. And how we determine these things, it's really about sea surface temperatures in the equatorial Pacific Ocean. So nowhere near Indiana. And that, I think, is one of the fundamental problems. But if you think of how big the Pacific Ocean is, we look right around the equator and we compare what temperatures are on one side of the Pacific to the other side of the Pacific. And then depending upon where it's cold or warm and at what magnitude, that determines what phase. So it's not where it's La Nina across our entire planet. The question is, and what does that mean for us in Indiana? This map shows kind of a composite of what it generally means in winter. So not all year, but that probably December, January, February timeframe. These are the patterns and conditions we can expect when there is a La Nina that takes place. And you see a big wet over Indiana there. There's also a hint around there. You see the red outline that it's also warm. So let's think about that, assuming that this pattern is true every time we have a La Nina. If it's warm and wet, what does that mean about snow? If it's cold and wet, that means we could get a lot of snow. If it's warm and wet, then maybe we're getting a lot of rain. And that can be risky because the ground could still be frozen. And if we get a lot of liquid precipitation, meaning rain, because the temperatures are too warm to sustain snowflakes, then that heavy rain is not going to stay and soak into the ground. Keith was showing how our groundwater supplies are below normal, our stream flows are below normal. So perhaps with this extra precipitation, we could have stream flows rise, but maybe our groundwater supplies will not replenish that much. But it's all teeters right around that freezing point. So I'm not saying we aren't going to get snow, but I would be hesitant to think about it too much further. Next slide. I went back and I looked at snowfall, and I picked a station, in this case in West Lafayette, Indiana, in Tippecanoe County. And I thought, well, how much snowfall is typically associated with these different phases, El Nino or La Nina? And then we've got to think about the strength of those phases. Now, down below the green table, I showed that the average Indiana annual snowfall, and that really should say in West Lafayette, is 21.8 inches. That is, I've averaged it over, I think, over 100 years. I had data for that. And now you can go back to the table and see, gosh, all of those amounts seem pretty darn close to the average, with the exception of when we have a weak El Nino or we have a strong La Nina. Otherwise, if we say we're in an El Nino or a La Nina, it seems like, I mean, can you really tell the difference, of like 1 or 2 inches at the end of an entire season? So I often tell folks, I don't think that El Nino, La Nina is a good indicator for snowfall. And in Indiana and just climatologists across the Midwest, there really isn't a good indicator for how much snow we're going to get. Now, where we're at right now is we are currently in what's called a moderate to a weak La Nina. So you could look at the table and say, oh, well, in the past, when it's been weak or moderate, that's been 20 inches. Oh, well, that's slightly below the annual average. We are expected that the La Nina will shift to a neutral phase come the start of the new year, so January, February. So look at the box down even below that says, gosh, during neutral years, the annual snowfall in West Lafayette has been 23.4. And for us, most of our snow actually does come near the end of January through the beginning of March. So I'm guessing we'll be in the neutral phase when we hit our peak snowfall season for the state. But I just wanted to point this out that if you're wanting to know what's going to happen in terms of snowfall, yeah, there's not a lot of guidance. I will say there's another pattern that is typical in Indiana when we are in a La Nina winter, and that is that it tends to start off extraordinarily mild. What do I mean by that? What I mean is December, if we think that December is the start of our 3-month winter season, December tends to be warm and tends to be wet, but not like flooding wet to the point where people are bummed. You're thinking, is there going to be a white Christmas? These temperatures seem too warm. But in past La Nina years, all of a sudden it turns around and kicks in so that by February and March, it is extraordinarily cold and there's a lot of snow coming in these storms. And you're kind of looking at each other going, why couldn't this have been spread out more evenly? So that's what I'm hedging for this upcoming winter season, is it's going to start off mild. We're not going to see too much snow, but there's always a chance that come February, March, we're going to see some pretty significant snowfall events. And that's how we get up to these totals. So imagine if we got that 20-inch total or 23-inch total in just 2 days. That's sort of how La Ninas do happen in Indiana. Next slide. Now, I've been talking about normal, above normal, less than normal, and all of those. That previous slide was about 1 point in the state. This is a map, and I apologize how small and difficult it is to perhaps see Indiana, but this shows the average annual snowfall latitudinally across the state, where in the southern part of the state, that total amount for the snow season is about half a foot to a foot. And then obviously we are impacted by a lot of lake effect snow in the northern part. If you're interested in seeing this particular map a little up close, then you can certainly reach out to me in the future. Next slide. This is an example of where I just also wanted to highlight what is normal. And here I'm looking at the 2 months at the end of a calendar year, so November and December. To give you an idea, the map on the left shows how much precipitation do we typically see in those 2 months, where we're thinking snow, when's the next snow, and so forth. Granted, we had snow earlier this week, but that was unusual. And then the map on the right shows how much snowfall do we usually get on the front end of a winter season. And those maps or those amounts are shown in the legend below, where really in the southern part of the state, it's fairly negligible. And then obviously we get a lot of lake effect snow in the northern part. But next slide, please. This is what the amounts are, and the scales at the bottom have changed to account for this. Now, once we get into January, February, March, how much snow happens there. So if you can remember in the previous slide, it was very little amounts even throughout the state, but now you can see we're talking 20, and in the northern part 30, even up to 40 inches. So that is our snowiest time of year. We've now got to think if that is normal, if that is average, and then we have these predictions based on it's a La Nina versus neutral year, what can we expect? Next slide. This is just a picture because I love snow and I really hope we get a good snowy season. So I think I hand it back to you, Keith.
Oops. There we go. Yeah, so we're just going to wrap up now. It's a pretty good time. So yeah, this is right. I just wanted to thank Beth for participating. I want to point out that if you go to the IWRRC webpage, that we do have a tab on there for the state of Indiana waters, your one-stop shop for water resources summary for Indiana. I will say, as of this moment, the web link there is still for the 2024 water year assessment. My meeting just before this webinar was with the undergraduate student who is nearly done with the story map for the 2025 water year. So I'm hoping to have that. Well, I have given you the QR code, which will take you to the website. I gave her some things to fix. So I'm hoping by later tonight, those things will be fixed and it will be linked into the IWRRC webpage so that everybody can go in and review all the things that I've shared with you. And that is the end of our presentation.
So I think we have a few minutes. Maybe Keith and Bethy can stay on if there's anyone. I haven't seen any Q&A in the Q&A section of the website of the webinar. But if there's anyone who has a question, you can raise your hand and I'll try to find you here in the list of attendees, or if you wanted to put anything in the Q&A section of the webinar screen. Going once, going twice. Well, I just like, oh wait, we have a hand. All right.
Yeah.
Now trying to find it. It's kind of funny. Okay. Melissa. Oh, I thought I let Melissa talk. Okay, Jill. Hi, Jill Hoffman. There is a question, so we'll just let okay, Jill start and then we'll go to Linda. Jill is asking, are you concerned about the 8 significant GW location changes? And maybe for the audience, I think this is for you, Keith. You can explain what she means by 8 significant GW locations, and then we'll go to Linda and also see then if Melissa can unmute herself for that question too.
Yeah, the GW. I got the GW is the groundwater. I think I have to, like I said, I had started to look back at the 2020 to see if there were any persistent changes, and I need to rerun those numbers to get them into a similar plot, but I'm curious to see if it has persisted. I don't specifically remember where they are because I don't have that in front of me right now. But I think they're fairly well distributed in the state, and I don't know that any of them were anywhere near the current data center locations. So I can't answer the question right now as to whether or not I'm concerned, but it is something to be paying attention to.
Jill, you can talk if you wanted to follow up on that to clarify your question.
Thanks, guys. Hey, first of all, you guys, really informative. I enjoyed your, break it down presentations today. Yeah, I was just, those changes, and maybe looking at those against the significant water withdrawal facilities. I know we see a lot of agricultural use up in that northern tier. And then, of course, as you mentioned, the data centers and stuff. So I would just say I'm curious too, Keith. So if you want to make that next step about whether that was persistent or just the blip of science, that would be great.
No,
hey,
I
thanks.
will have a look at it.
Thanks, Jill, and we'll see you tomorrow. Just a reminder, we also are sponsoring with the White River Alliance tomorrow a seminar on coal ash. So that is on our website. And I'm going to go to Linda Lee and allow her to talk.
Okay, I put it in the chat. So this is a challenging question. So given what you found with drought and groundwater level trends, when you think about Indiana's desire to bring in more industry and businesses, how do you suggest we support both needs? Like, how do we play the role of the honest scientist to recognize our limitations and acknowledge that we have a certain amount of buffer, but we also want to help the state increase their economic capacity and workforce opportunities? So this is a hard one. I realize that.
It is a hard one. I mean, I think this kind of gets fundamentally to the governor's executive order and the ongoing effort by the Indiana Finance Authority and others to quantify Indiana's water resources now. Because we keep talking about, like I showed you changes over the last 30 years, but quantifying what that means, right? A significant decrease in groundwater in a very large aquifer may not mean much for the volume of water.
Yeah.
So there's a lot of interpretation that has to happen, and I hope that we can all continue to work together, the researchers and the agencies in the state, to try to get a better handle on all of that.
So what do you think what do you think we as faculty at the academic institutions in Indiana should be doing to, address this problem with tools that are really being pushed to enhance all the needs of the data center further, but AI and machine learning, right? So that's even, tricky. Like and I know that there's been a lot of talk, about digital twins and things like that, but what can we propose? And, if the states gets to a point where they're saying like, yeah, how can we economically capture this? They need way more than that. So what role should we be playing? Indiana's not great at giving, financial allocations to institutions to do certain things. They just expect us to find it on our own. Sorry. But, what should we be doing in that space? Because it's not something that we can, that we would benefit from just, incrementally making advancements by our normal approaches to our research. We really need to use higher level predictions and AI machine learning type things, which, everybody's wanting to see get exploited, so to speak. So what's your thought on that?
Another big question. I mean, I
I
think
know.
I think we need to look for ways to continue to support research in the state and how to bring more of that, I guess, more to work with agencies to make sure that the research that we're conducting is at least useful at addressing some of the questions, concerns that they have on their plate at this point. They are being asked to monitor or regulate other, I mean, I don't know if regulate is truly the word yet, but certainly to monitor what's happening and respond to it. And so we need to be able to give them quality data and an analysis that can help them do their jobs. And yes, we have to work on looking for other sources of money, but
Yeah.
All right,
So
Linda, we need to move to an easier question for Keith that I want to address
okay.
from some of
I'll
those
text it.
open. Okay, yeah. You have
You can
easy
text me.
access to Keith. You can walk down the hall or the other building. One of our attendees asked about your thoughts on home rainwater collection systems and if those are beneficial given the tension between drier conditions and heavy rain events.
I would say that I would encourage exploring that. We continue to have and are forecast to continue to have wetter winters and spring conditions. But the precipitation in the summer is projected to kind of be about the same to maybe decreasing. And certainly air temperatures are increasing, which means that water availability in the summer is decreasing. And so I think one of the things that we really need to be looking at the state level, but even in the Midwest in general, is how do we store more water in the landscape when we have it? And so if it's
Takes
your
us back
property,
to wetlands.
we need more wetlands. We need more
wetlands.
storage ponds. We need maybe to start
Mm.
looking at storage of water in the drainage canal, the drainage canals and other things.
Mhm.
Different ways to manage our water. Historically, we've drained Indiana to flush that water downstream, so that the fields are ready to plant in the spring. But wouldn't it be nice if we could keep some of that water around for July, August when we need it? So yes,
Great.
putting in water collection systems is going to be an important part of that.
But then right now we're all disconnecting our water barrels so they don't freeze.
Right. Yeah.
over
If you have a
winter.
water barrel, you should have it drained and disconnected at this point.
One last question before we close, and maybe Linda might not even know this more than you do. I don't know. Any specific studies on emerging contaminants such as pharmaceuticals or microplastics? I imagine we'll throw PFAS in there too. In our local waters. I'm not sure where this person is located, but we can answer that. I think locally and across the state.
Am I still live?
You're still
still
live.
live.
Please.
Well, you
Yes.
must have read my mind, because I said, how do we fold in water quality issues with the trends that you're seeing with water amounts? And that's a really good question. And Lynn, you played into it without knowing I sent it. What I'm learning in some of our counties is I didn't realize how much karst landscape we have, but in some areas we do. And the water that we're looking, some of the water that we're now looking at, it's not good. And then you couple that to the fact that these industry also need higher water quality than oftentimes they can get. So I do think that we have a pretty big issue. That's why I think we need to, like right now, we might not have emergency across the state, but we definitely see the trends, and we should not be like Australia and not think about water quality and only quantity until later. We should think about the whole story. And so I think we just have to get really creative. That's why I think about how, like, what I do normally, my normal approaches would never get a suitable answer quick enough for, a whole state, let alone a county. So this is why I was saying, coupling all of our modeling expertise that we have, our advancements that we're starting to make in the AI space, be able to grab numbers from all over the state. Because ideally it would be great to say, where are we? Are we in trouble with what we have? Maybe we can manage, but now we want to bring new industry in, and can we tell them, hey, this is a better county for you to put it in, or this area is a better place for you to put it, given the water resources that are needed and things like that. So I know
Yeah.
that's a big thing, but I think that's what we should be working towards in this space.
So it might also be useful to note that in Indiana, the drinking water is tested on a regular basis for contaminants, including PFAS. But our wells, if you are drinking water from well water, there's more limited testing. So you might want to consider getting your well water tested, because it is not assured that it is free of contaminants the same way that city or municipal waterways are.
It's interesting when it comes out to be positive in the drinking water, that raises, the eyebrows, and they start investigating it. And then when some industries end up having outputs of contaminants that they don't understand why they're having these contaminants, it leads to their wells, because, industry can't just use city water. They usually have to make it up with quite a bit. Then they find out their wells are highly contaminated, which is why their outfall is contaminated. They're not actually
Contaminated
creating it.
in, contaminated out.
Yeah, so we definitely have, I guess, a fun challenge, but it is before us, and we probably shouldn't wait until the alarms go off.
Well, thank you all for, I think, a really fantastic presentation. And as Keith said, the data on the IWRRC site will be up to date soon. I also want to point out that ISF does also have resources on groundwater and surface water and some other things. We will be sending out an email to all the registrants with the link when we upload this presentation to our ISF YouTube page. So I'll also put in links to those resources, which are also useful. And just for kicks, I'll also put in the link to our latest PFAS report, because we've talked about it and we have it. So thank you very much for your participation. And please, you will also get all the links, and you can share those with others as well. So thank you very much, Beth and Keith, for a fantastic Water New Year presentation. I learned a lot, as always. Thank you.